This is Senior Algebra Section 1.8. Today we're looking at simplifying expressions, identifying terms, numerical coefficients, combining some like terms, identifying like terms, simplifying some expressions. We did a little bit of this yesterday and we're going to continue it today. So a few definitions here to start. First, a term. When we say like terms or terms, well, what is a term? A term is a number, variable, or a product or quotient of a number or numbers and variables raised to powers. So, keys in this one that we look at, a number, okay, it could be 3. That would be an example of a term. Okay. 3x. Well, what does 3x means? 3 times x. That's a product, okay? Has variables in it, so it could have just a single x. That would be fine. Could have a negative 5x squared y to the 5th. Okay, all those are products, so that would be considered one term. Even though there's a lot of different parts to it, there's one term. Could also be the quotient. So I could have 2 over 5y. Okay, that would be an example of a term as well. It could be raised to powers here like we did in the second one where we had negative 5x squared y. And then we have another example of a quotient here. So when we talk about the next term, which is like terms and numerical coefficients. So the first one, numerical coefficients. The numerical, when we say numerical, we mean the number factor of a term. So if we look above, when we looked at our terms here, what is the numerical factor of the term? What's the number associated with it? So in the first one, we have 3 there. There it is. In the second one, 3 as well. In the third one, what number is associated with it? Negative 5 in that term. In the fourth one, a little bit tricky here, but we have the fraction 2/5. That would be considered the numerical coefficient. Okay. And then the last one, just negative 8. So those are examples of coefficients. Okay. It's the number that's associated with the term here. Then the last one, like terms. When we talk about like terms, we look at 2 things. They have to have the same variable, same exponent. So they have to have the same amount of x's, y's, that type of stuff, z's, those variables that we've looked at. The same exponent, they have to be raised to the same power. Okay, same variable, same exponent. So some examples of what we consider like terms. 3x and negative 8x. Are the variables the same? Yep, they're both x's. Are the exponents the same? Well, yeah, that's 1 and 1. So same variable, same exponent. If we look, 5x squared y. Like terms have to have the same variable, same exponent. So they both have an x and a y in it. The x is raised to the second power. The y is raised to the first power here. We put a 1 in front of the x squared y. You don't need to, but you could. Just like we could put a 1 in front of the x. Some examples of things that are not alike. Unlike terms. 3x, 5y. This has an x, that has a y. And then the other one, the confusing one, is when we have an x and an x squared. Those are not like terms. They have the same variable, but they do not have the same exponents here. So a couple examples here. Looking at example 1. First thing I want to do is I want to look at and see what I could simplify a little bit. So I look at the minus negative 10, and I realize I should simplify that before I start moving stuff around, before I start combining like terms. Now remember, minus and negative, that just means plus here. So I'm going to rewrite it. Okay. 5x plus 3y minus 7x squared minus 9x, and then plus 10. Remember, we add the opposite, so adding a negative is really, or adding a negative 10 is going to be plus 10. So minus a negative is really plus 10 there. That's what I meant to say. So I look, what are my like terms here? What can I put together? Well, I take a look. I have a 5x and a negative 9x. Okay, those are alike. They both have x's in them. Notice I can't put the x squared in there. That has a squared, that one doesn't. The other one, 3y and a 10y. So I'm going to first start, when I write these out, I'm going to write out my largest term first, usually negative 7x squared. Then from there, I'm going to put my like terms together. So I have a 5x and a negative 9x. When I add those, 5 plus negative 9 is negative 4x. And then finally, 3y and 10y. If I have 3 positives, 10 positives, I have 13 positives. So I have 13y. So my final answer would be negative 7x squared minus 4x plus 13y. In B, we're going to do a little bit of distributing when we get to it. Here we go. So I'm going to look at this, I'm going to do a little bit of distributing, and then I'm going to be combining some like terms. One of the most common mistakes that I see is that negative 3 here. First, I know that I can't subtract those, 5 minus 3, because order of operations. I have to distribute the negative 3. So I could change it to plus negative or add the opposite. But I do have to distribute the negative 3. So negative 3 times 2x is a negative 6x. And negative 3 times a negative 8 is a positive 24x squared. I'm going to finish writing the 6x minus 2 plus 3x squared. So then I look, what can I combine together? Again, for me, I like to either circle it, box it up, something like that to kind of that. You can also group them together. That would work. So I have 24x squared and I have 3x squared. Those would go together. Other ones, a negative 6x and a positive 6x there. I can put those together. They both have x's. And then finally, I have a negative 2 and a positive 5. So I'm going to start with my 24x squared and the 3x squared. When I put those together, positive 24, positive 3, that gives me positive 27x squared. Remember, we looked at why it doesn't become x fourth. We could pull out the x squared and do that stuff. We looked at that yesterday. Then I look, negative 6x and 6x is 0, and then 5 and negative 2 is 3 here. So in F here, factor out the common term. We say the common term, what is in both of them? 8, 20, and 4, I can pull out a 4. So if I pull out a 4, 4 times what is 8x, that's 2x. 4 times what is a negative 20x, that's negative 5x. And then the one that people forget about, 4 times what is 1. I have to put the 1 there for the placeholder. Now, some people might have looked at it and said, well, could I simplify that inside? Sure. I could have wrote it as, finally, negative 3x plus 1. But notice here, I could have simplified it at the start as well. If I put together negative 20x and 8x, I would have got negative 12x plus 4. Well, what's common in negative 12 and 4? A 4. So I could have taken out a 4. I get the same answer here. I pull out the same common term, which is 4. Okay? Just a little different way to think about it here. And then the last one here, we're translating phrases. We've done some of these. This one's a little bit tricky. So I look and I see 7 times a number added to 5. And we know times is multiplied. So I'm 7 times what? A number. Okay, so those are the two things. And then added to 5. Then I look and I have subtracted from. And that's the tricky part here. Subtracted from. Well, that means I'm going to take that first part, the 7x plus 5, away from something. So I have to put that in parentheses because I'm taking the whole thing away. Now, I'm going to rewrite it here. I'm going to write minus and then parentheses and then the 7x plus 5 there. What's going to go in front here? Well, it says we have triple the sum. Okay, triple, what does that mean? That means multiplying by 3 if I triple something. The sum, the answer I get when I add here. So what things am I adding? I'm adding 12 and, oh, there's a 12, the product. Product is, of course, what I get when I multiply here. So 9x. Okay, I have to put that in parentheses, so it's triple that sum, and then minusing the 7x plus 5 there.